So today we will be discussing Claisen condensation reaction. It is basically synthesis of ethyl acetate. In this reaction, we treat ethyl acetate with a base followed by acidification, and we get the product which is ethyl acetate. We have already done it in the enolate synthesis. Application of ethyl acetate finds its application in a lot of organic synthetic reactions. So this product is called ethyl acetate. It is interesting that reaction is ester analog of the aldol condensation. What happens in aldol condensation? In aldol condensation, we have an aldehyde or a ketone. So here I have taken example of acetaldehyde. Acetaldehyde reacts with acetaldehyde in the presence of a base to form the product that is called aldol. Now, what is the basic mechanism of the reaction? That the alpha hydrogens, the carbon attached to carbonyl group is called alpha carbon, and these hydrogens attached to alpha carbon are acidic in nature. So when you treat an aldehyde with a base abstracts these protons and water is removed, we get a nucleophile. This nucleophile attacks the another molecule. Now what is the force behind generation of this nucleophile? Because this nucleophile is stabilized by resonance. Here we can see. And same happens in the case of ethyl acetate. In ethyl acetate, this is the alpha carbon. These hydrogens can be extracted by a base. The base in this case is ethoxide ion. Ethoxide ion will go off as ethanol, forming a nucleophile. This nucleophile is stabilized by resonance. We can draw its resonating structure. CH2, so double bond CO negative and OET. So that is the reason behind formation of this nucleophile. Next we will be discussing the mechanism of formation of ethyl acetate, that is Claisen condensation reaction. So mechanism of Claisen condensation can be discussed as already discussed, the alpha hydrogens in ethyl acetate can be moved by ethoxide ion, which is a base. Now ethoxide ion can abstract this proton and leaving these electrons behind. So जब ये hydrogen चला गया, ethoxide ion will be converted into ethanol. So the ethanol is formed and we get a nucleophile. Now the important thing about this reaction is the JSC, the reversible reaction. The reaction is favored in the backward direction because ethanol has pK value of 16 and while ethyl acetate has pK value of 25. It means ethanol is a stronger acid. Ethanol has stronger tendency to lose a proton, hence the equilibrium is favored in the backward direction. But once the nucleophile is generated, it will attack the another ethyl acetate molecule. That will be the second step. Let us write the step. And in a nucleophile, this carbon ion will attack at this carbon. Why? Because it is electrophilic in nature. This carbon has partial positive charge because it is attached to an electronegative oxygen atom. Now to maintain the tetravalency of carbon, this pair of electrons will be shifted on oxygen. So we get this product. Again, we can see the step is reversible but more favored in backward direction. So the formation of this product also results in elimination of ethoxide ion. So we can write it, this negative charge will restore the C double bond O and expel ethanol, ethoxide ion. So what do we get? In the next step, so finally we get ethyl acetoacetate plus ethoxide ion. Now this is interesting कि ये जो CH2 group है, this group will be acidic because it can lose protons, being surrounded by two carbonyl groups and an ethoxide ion. So what will ethoxide ion do? It will abstract a proton from here, giving us an enolate. So the reaction is the equilibrium reaction. Enolate ion बन जाएगा So this enolate, as you already know, this is stabilized by resonance. That negative charge can be dispersed on this side and also on the other side. So this is stabilized enolate ion. So what we do finally to get ethyl acetoacetate, the next step is we acidify the product giving us ethyl acetoacetate. So to shift the equilibrium in forward direction, what you do is you keep on removing the product formed, and one of the ways is the flask in which product is kept. The flask in which product is being collected, it is cooled, its temperature is kept low, and the product keeps on collecting there, and reaction is pushed in the forward direction. Now try doing a written practice of this, write the mechanism, and next I will be giving you some questions for solving the Claisen condensation. We will discuss cross Claisen condensation reaction. Now we are discussing the cross Claisen condensation. Now whereas you can easily look, the reaction is between these two substances. Who will tell the name of this substance? Think of what is the IUPAC name of this substance? Okay, I will tell. This is ethyl benzoate. So what is so particular about it? It is interesting that it does not have alpha hydrogens. So where are the alpha hydrogens? It is only here. You can see that the nucleophile generated in the reaction will be from this, and it will attack this, and subsequent elimination of ethoxide ion will give us this compound. So this is an example of a cross. aldol condensation reaction in which the two reactants were different. Now students, try solving these three questions based on our discussion. Note down these three. Ethyl acetate plus acetone in the presence of sodium ethoxide. की प्रोडक्ट बनेगा इन्हें सॉल्व करने की कोशिश करो. I will put the answers in the group. Ethyl and butyrate in the presence of ethoxide ion. Ethyl propionate plus cyclohexanone in the presence of ethoxide ion. We have taken these problems from organic chemistry by Morrison and Boyle. So solve these questions.